this is Mr. Coates, and this is APES Lecture number 25 on oil. We just learned about the different types of non-renewable energy sources and fossil fuels, and oil was a huge one. So we're going to take that one by itself and kind of look into it a little bit deeper. So when we talk about oil, we're talking about crude oil in the ground. Anytime we talk about oil in the ground, it's considered crude oil. That means it has not been refined. It has not been treated to form all the different compounds that were in it. So that's important to realize that crude oil is basically a bunch of liquid of different types of hydrocarbons and small amounts of sulfur, oxygen, and nitrogen as well. But it's not just oil. I mean, it has a whole bunch of different things. It's kind of like seawater. Seawater is just not salt in water. There's a whole bunch of other things mixed up in there. And so when we use crude oil, we actually have to separate these things out. And we'll talk about that a little bit later. Now, the problem with burning oil, obviously, we've talked about CO2 emissions. Huge problem with burning fossil fuels. Now, when we extract oil out of the ground, we actually have to drill it out of the ground some fashion. And so we do that by creating a drilling rig, which is this right here. And this drilling rig drills down into the earth. And usually what happens is that underneath the earth, there's usually some kind of impervious rock layer, which is this layer here. And that traps the oil. We drill down to where we find this reservoir of oil, and then we pump that out. And a lot of times when we pump that out, we'll pump water back in there to kind of force the oil up to the surface. Also, usually trapped at the surface of this reservoir is natural gas. And sometimes if it's a big enough reservoir, we'll pump this out as well and use it. If it's not very big, what happens is that usually near a drilling rig, you'll find a flame. And so this flame will be degassing off this excess natural gas, so there's no explosion. Unfortunately, that's a huge waste of natural gas, but the oil companies do this because it's not worth their effort to actually save that natural gas. The oil is actually a better profit for them than the natural gas is. So this is how oil is found. We look at the different layers in the earth and we find that layer that might trap oil, then we drill down to it and extract it through the well and the pump process. Alright, so where can we find oil in the world? So this is a map of the 2012 proved oil reserves. Remember, an oil reserve is where we know there's oil in the ground and we know approximately how much is there. And so if we look at how much oil is around, the countries that are the darkest color, which is this color here, Saudi Arabia. Saudi Arabia has the world's largest reserves, and Venezuela also has a huge amount of oil in it down there. Unfortunately, both these countries are owned by governments that don't necessarily like us. We work with them, but they don't necessarily like us, and so we sometimes have to get our oil from other places. Now, if we look at the United States here, okay, we are at this area here where we have about 25.4 billion barrels of oil reserves in us, okay? And so that includes all the oil that's offshore here in Texas and also our large Alaskan reserves here. Canada actually has more oil right now than us, and this is the importance of the Keystone XL pipeline that they're trying to build through the country, and we'll talk about that a little bit later. And then you have countries that have hardly no oil reserves whatsoever. Australia, for example, a major developed country, has hardly any oil reserves whatsoever. They have to get all their oil from other countries. Same thing goes for a lot of the European countries here. And so one of the questions to ask yourself is like, what's going to happen to these countries that depend mostly on oil, that have no reserves whatsoever, and the prices start going high when we start getting low amounts of oil? So who controls the oil? Well, the OPEC does, the Organization of Petroleum Exporting Countries. They actually set the price of the world's oil. And these countries own 60% of the world's oil. And obviously Saudi Arabia is a big one, UAE is another one, Venezuela, we look at them, and then of course our buddies in Iran and problem areas in Iraq, so forth. So a lot of these areas that have the oil and that control the oil are usually not our friends. And so that creates problems for us and is one of the major reasons why we deal with the Middle East in the first place. Other important producers, Alaska. In fact, Alaska is our biggest producer here in the United States right now. Russia has large oil reserves in Siberia, and Mexico also has large oil reserves. These guys are not in OPEC. Okay? OPEC's a very wealthy organization. The revenue in 2013 equaled about $826 billion. And if you figure that down to how much money that is a minute, that's $1.5 a minute for that year. Needless to say, those countries are making a ton of money off of the rest of us by selling us oil. Where do we find oil in the United States? Well, most of our oil is found, like I said, usually off the coast of Texas and Louisiana, down here in the Gulf of Mexico, and we find a lot up here in Alaska as well. And so Canada also has very large reserves here, but in the United States, we really lack in oil reserves. We don't have a whole lot, and so we usually have to import our oil. Now, recently, this is 2014, recently the United States just exported its first cargo of oil, and that's because this area right up here in North Dakota is the area where we're producing a lot of oil in our country right now through the process of what we call fracking, and I'll get into that later. But because of that, we are exporting oil now, and we've got a surplus, and this is why our prices in 2014 are lower than what they were in 2013. Now in the United States, like I said, we have 2.3% of the world's proven reserves, but unfortunately we use 30% of the world's oil reserves. And as I mentioned earlier, most of that goes for transportation. If the United States can figure out a way to improve our efficiency in transportation, then our use of the world's oil will definitely drop. And so this comes from using hybrids and also using mass transit. And unfortunately in the United States, mass transit has been a big issue, a big problem. A lot of Americans don't want to give up their cars. Now, if we look at prices at the pumps in 2011 here, and we're looking at per liter, so it's not per gallon, so be aware that they're about 3.75 liters in a gallon. So we were paying a fairly low price compared to the rest of the world. So they're paying $1.50 here, $1.50 per liter in the Netherlands. We extrapolate that out, we're looking at about $6 a gallon in the United States. Can you imagine the uprising that would occur in the United States if we were to pay $6 a gallon? There'd be long lines at the pumps, and it would be terrible. And so here in the United States, our gas prices are fairly low. So why is that? And that's because the government subsidizes the oil companies. In order to keep prices low in the United States, the government actually gives subsidies, which are free handouts basically, to the oil companies to stimulate economic growth. And unfortunately, the negative impact of this is that they have really stalled the ability for other companies to come about and get energy efficient type methods of energy production, like renewables. So improvements in our energy efficiency have really gone by the wayside because our oil and gas here has been so cheap. And the oil companies love this. They don't want to see solar come into the forefront. They don't want to see wind come up because they like making their money on oil. And so consequently, the oil companies have huge lobbies in the government, and the government keeps on giving them money, so the prices are artificially low. So I mentioned before that most of the oil pulled out of the ground is called crude oil. So in order for us to use this oil, it has to be refined. And so when oil is pumped out of the ground, it is shipped to a refinery. And so this is where a distillation process happens. So we ship it either by pipeline, and this is the Trans-Alaskan pipeline here that takes the oil from the north of Alaska and pumps it down to the coast of Alaska where tankers can pick it up. And then we have wells here that will pump, and we'll have pipelines and tankers, both trucks and ships that will move the oil around. But in order for us to use it in our cars, it has to be refined first. So let's look at that process. So this is how a refinery works. What you have is what we call a distillation column, which is this thing here. And this distillation column has different levels in it. And so at each level, there is a different temperature, or a plate. And each plate has a separate temperature associated with it. So if we look, we have 170 degrees Celsius here, 270 degrees Celsius here, 600 degrees Celsius here. And so this is all based on the melting point of the different types of compounds found within crude oil. So what happens is that crude oil comes into this and it heats up, and it heats up to this 600 degrees Celsius. And so because it heats up, it turns into a gas. And so as the gas makes its way through this, we start to cool down. And every step we get a different type of chemical out. So that type of chemical has a higher boiling point, and so it will come out first. So the first thing is fuel oil that comes out. And so fuel oil then can be used to fuel ships and factories. The next thing that comes out is like lubricating oil for engines and for other industrial processes. Next comes out is diesel oils, and then comes out kerosene or paraffin oil at that point. And then up here is gasoline. Gasoline comes out at 120 degrees Celsius. This is basically the boiling point for gasoline. And below that we have liquid. Above that we have gaseous gasoline. And then we finally get up to the top where we get petroleum gas up here, which has the lowest boiling point. You could basically see that. Obviously gases have a very low boiling point, or else they're not gases at room temperature. So as the oil makes it up and as a vapor up through here, different compounds are extracted out. At the bottom here we get a residue out, and the residue is usually used, it's called bitumen, which is this word right here, bitumen, and it's usually used in asphalt and also shingles. So this is all the different things that oil can be used for, and it's all due to fractional distillation. This is an important concept for you to know how it works. It works on the boiling point of each type of chemical coming out of the crude oil. So are we finding new oil? That's a good question. The answer is yes. However, all of the easy to find oil has pretty much been extracted from the earth. We are now locked into finding really difficult areas in order to get oil out. However, even though we're finding new ones, the flow rate of oil is decreasing. We're still not pulling out as much oil out of the ground as we used to be. So what does this mean? What does the decline in flow rate of oil mean? Well, it means that price will increase. We don't see that here in the United States right now, but eventually the price will go back up. Eventually it'll become so expensive that it won't be useful to use oil or gasoline in our cars anymore. Once again, that could be thousands of years down the road, but it'll eventually happen. Other things that happen, food production becomes maybe more localized because it becomes too expensive to truck the produce around. Airfares possibly go up, leading to less travel by air. We've actually seen this because airfares have gone up and less people are traveling. Vehicles increasing their mile per gallon standards. This is also known as the CAFE standard. This is the corporate automobile fuel efficiency standards that the government has set up. And the other thing that can happen is that it might lead people out of the suburbs and back into the cities because it's too expensive to commute. So all these things could possibly happen with the continuing decline of oil. So where can we find some more oil? We've got to realize that oil production in the United States is much more expensive than anywhere else right now. So right now our option is to buy foreign oil. New oil field discovered in the Gulf of Mexico might provide oil for the U.S. for about 5 years. That's not very long. We use a lot of oil, and so discovering a new field doesn't last very long. Could there be oil off the coast of Florida? I'm sure there is, but thankfully the state of Florida has decided that their tourism is much more important to them and their beaches are much more important to them than to allow offshore drilling. Now in the future that might be a decision that comes back up. There might be a government at that point, or oil prices might be so high that people do vote to allow offshore drilling of Florida. If that happens, then our coast will definitely change, and the port of Tampa will definitely change because the amount of traffic coming in and out of our port because of offshore oil drilling off of Florida will increase probably 10-20 times. Now the last possibility is ANWR. A lot of people talk about ANWR, which is the Arctic National Wildlife Refuge. In fact, the famous Drill Baby Drill campaign when Sarah Palin actually running for presidency, when they wanted to drill the Arctic National Wildlife Refuge, and there's a lot of oil reserve there. However, if the United States hangs on to that reserve, it will only supply us for 5 or 6 years as well. So ANWR is not the answer, and drilling for more oil is not the answer. Even though they campaigned on this and didn't win, obviously, but her famous campaign slogan was "Drill, baby, drill." So if we look at the ANWR itself, ANWR contains about 1/5 of the land in the United States National Wildlife Refuge. It is a huge wildlife refuge. It was set aside by, I believe, Jimmy Carter, and the coastal plain is the only region that's not open to development for oil and gas at this time. And the oil companies know that the coastal plain is very rich in these deposits. there are some major concerns with actually drilling for oil in there. First of all, tundra is very fragile. It's a very fragile ecosystem. It takes a long time for it to rebound. And so if you disturb tundra with trucks moving in and out, or oil rigs or oil pipelines, things like that, it takes a long time for that to come back after those things are gone. And that's because the primary productivity in the tundra is so low. Now, as I said before, the amount of oil in ANWR is very low. If we were to use this oil worldwide, only 7 to 24 months of oil exist in ANWR. It's not that much. Once again, the CAFE standards come up. It'll be much easier to raise gas mileage standards on cars and automobiles in the United States rather than drilling in the National Wildlife Refuge. We'd actually extend our oil use far more than actually drilling and getting this 7 to 24 months worth of oil worldwide. The last point about oil is it's messy. Unfortunately, with oil, there are accidents and spills that happen. You hear about them quite a lot when they happen. However, they're not that often. But when they do happen, they create a lot of environmental damage. One of the biggest here in the United States was the Exxon Valdez back in 1989. We had a tanker that was carrying crude oil from Alaska through the Prince William Sound, which is off the coast of Alaska here. And unfortunately, the captain was drunk, and he ran the ship aground and consequently spilled 11 million gallons of oil. And this oil created a whole lot of environmental damage. A lot of fisheries were damaged to the point where they couldn't be fished for quite a while. Over 250,000 animals, mostly birds, died within months of the spill. That's because their feathers were coated, or they ingested so much oil that it killed them. And so this was a huge newsmaker when it occurred. And they spent months and months cleaning this up. They pressure washed all the rocks where it occurred. Millions and billions of man hours are used to clean it up. And today you can still go there, pick up some rocks off the shoreline, and look down, and you'll still see an oil sheen underneath those rocks in water. And so the oil is still there in some form. The other accident that has occurred was the Deepwater Horizon in 2010. This was more close to home. This one occurred in the Gulf of Mexico, which is this rig right here. This rig had an explosion on it, and when the explosion occurred, the rig actually sank, and the pipe that it was very deep under the water broke off right at the bottom, and so consequently oil just spewed out of this pipe. And it spewed out for several months because this area was so deep they had to use robots to try and close it off. And so it took a lot of time for these robots to actually close and cut off the spill. Consequently, 210 million gallons is estimated to have spilled from this. Fortunately, the environmental effects don't look to be that bad. However, they're still being assessed. It looks like most of the oil stayed offshore and was consequently naturally degraded. And that's one of the things about crude oil. Crude oil can be naturally degraded by bioactivity. And so when oil is released in the environment, there are some organisms that can break the oil down. And so the thinking is that some of this oil did sink to the bottom, and microorganisms like bacteria actually broke down this oil into simpler compounds. So that's one of the good things about crude oil. You can't do that with refined oil. Once the oil is refined, the organisms won't break it down. So we have these major spills. Now, there have been other major spills throughout the world, but these are the two biggest in the United States. Well, I hope that was helpful in getting you to understand the oil issue in the United States and the world. And so have your notes ready to go in class when this video is due.